Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 6.1, Graphing Radical Functions, Day 2. Today we are going to look at the radical function, the cube root of x. So the radical parent function is f of x equals the cube root of x. Just like with our square roots, we're going to have certain numbers we're going to put in for x every single time because they're extremely easy to find the cube root of these numbers. The numbers are going to be -8, -1, 0, 1, and 8. What you need to remember is that the cube root of -8 would be -2, the cube root of -1 is -1, cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. Okay? At this point, we can go ahead and graph our parent function. So if I go to -8, 1, 2, 3, 4, 5, 6, 7, 8, and then down 2, I get my first point, -1, -1, 0, 0, +1, +1, and then 8, 2, so 2, 3, 4, 5, 6, 2. Go ahead and connect my points. Every graph that we do that is a cube root is going to look just like that graph. All we're going to need to do is be able to move it around and stretch it at times, okay? So the domain and range. The domain is talking about what x values could possibly be on this graph. Well, since it goes on forever and ever and ever, both right and left, and I have no asymptotes, it will be all real. For my range, technically this is still moving upwards to the right and downwards to the left, so that will also be all real every single time. Okay? So we'll never really have to think about the domain and range. You will have to put it down every time, but it's always just all real. Just as with the rational functions, there can be transformations with radical functions. F of x equals, add an a to that please, a times the cube root of x minus h plus k. We're going to treat that exactly the same way as when we had our square roots. All those numbers are going to do exactly the same thing they did to our square roots. So the transformation caused by a is a stretch by the factor of a. When a is greater than 1, it will stretch, and when a is less than 0, it will reflect over the x-axis. Okay? The transformation caused by h is a horizontal translation, and the translation caused by k is a vertical translation, exactly the same as what we saw with the square root functions. Now, just like with our square root functions, we need to look at each piece and tell what it's going to do. So the first thing I run into is this 2. Since it is in front of my cube root, it's going to stretch my function by a factor of 2. The next thing I'm going to run to is this -1. The -1 inside of the cube root is going to be my horizontal translation. And always our horizontal translation, we're going to go opposite the sign, so it will be right 1. Now, just like the square root function, I'm only going to use from x to the front of my function for my table. So it'd be y equals 2 times the cube root of x. The numbers I always use for x are -8, -1, 0, 1, and 8. So remember from just above on the top in our parent function, the cube root of -8 is going to be -2. Well, -2 times 2 would get me -4. The cube root of -1 is -1. -1 times 2 would be -2. The cube root of 0 is 0. 0 times 2 is 0. The cube root of 1 is 1. 1 times 2 is 2. And the cube root of 8 is 2. 2 times 2 is 4. I can go ahead and plot these points now. So go to -8. 1, 2, 3, 8. And down 4. 1, 2, 3, 4. Then I go to -1, -2. 0, 0. 1, +2. And then 8, +4, so 2, 3, 4, 5, 6, 7, 8, 3, 4. And just like with our square root function, our table went and took care of took care of the stretch by a factor of 2. So now we're going to have to move everything to the right 1. So just like with our square roots, I'm going to go ahead and make this a dashed graph that connects all these points. In order to get my solid graph, my answer, I need to move everything to the right 1. So I'm going to take this point, move it to the right 1. I'll take this point, move it to the right 1. This point, move it to the right 1. This point, move it to the right 1. And this point, move it to the right 1. As I graph, I need to connect all my points. It might cross over a little bit, but it should be pretty well on the same line. They should be parallel to one another, okay? So, my domain and range always is just all real, because as you can see with my red graph, it goes on forever and ever and ever to the right, and on forever and ever and ever to the left. And my range is talking about the up and down movement. It's going to go down forever to the left and up forever to the right, so that is also going to be all real. Okay? Let's go ahead and move on to the second problem. The first thing I run into is this negative in front of my cube root. Just like with the square root function, if there's a negative in front of the square root, it's going to reflect my function over the x-axis. I don't have anything underneath the cube root, but I do have a positive 1 on the outside of the cube root. So that is going to be a vertical translation. A vertical translation up 1. Again, I'm only going to use that portion forward, the x forward, for my table. So y equals negative cube root of x. The numbers I put in for x always, negative 8, negative 1, 0, 1, and 8. Now, the cube root of negative 8 is negative 2. Negative 2 times negative 1, because that's really negative 1, would be positive 2. The cube root of negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Cube root of 0 is 0. 0 times negative 1 is 0. The cube root of 1 is positive 1. Positive 1 times negative 1 is negative 1. And the cube root of positive 8 is positive 2. 2 times negative 1 would be negative 2. If I go ahead and plot these points, go to left 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 2. Go to the left 1, up 1, then I have 0, 0, right 1, down 1, and then right 8, so 2, 3, 4, 5, 6, 7, 8, down 2. Again, this is my guide to how I will graph my actual answer. Now I need to have my vertical translation up 1 from everything. So I'll move every point up 1 and graph all of those. Now for my domain and range, as you can see from our red graph, which is our answer, it's going to go on forever and ever in both directions, so it's all real. It's going to go on up to the left and down to the right forever, so my range is also all real. Okay. On to number 3, which is not our final. I'm sorry. There'll be one more after that. I have nothing in front of the cube root, so I do not have a reflection and I do not have a stretch. The first thing I'm going to run into is this negative 2, which is underneath our cube root sign. So that means I have a horizontal translation. I'm going to go opposite the sign, so right 2. This positive 3 tells me I have a vertical translation. Since it's outside the cube root sign, I'm going to follow the sign, so it'll be up 3. I'm only going to use that portion of my function for my table, so y equals the cube root of x. So I have negative 8, negative 1, 0, 1, and 8, like I always do. Now for this, for my y, all I have to do is find the cube root of each one of these numbers. Well, the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. Cube root of 0 is 0. The cube root of 1 is 1, and the cube root of 8 is 2. Go ahead and plot these points. So I go left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 2. Left 1, down 1, 0, 0. Right 1, up 1, 2, 3, 4, 5, 6, 7, 8. Right 8, up 2. That is my guide graph, which will show me how my answer will work. From here, I need to take everything to the right 2 and up 3. So I'm going to take this point to the right 2 and up 3. The next point I'm going to take right 2 and up 3. This point right 2, up 3. This point right 2, up 3. And this point right 2, up 3. Now I can go ahead and connect those points to make my answer. As always, I do need my domain, which is all real, and I will need my range, which is also all real. Okay. On to our final graph. F of x equals negative 3 times the cube root of x plus 4. Since I have a negative in front of my cube root, it's going to reflect over the x-axis. The 3 tells me I'm going to stretch by a factor of 3. And then this x plus 4, this positive 4 underneath the cube root, tells me I'm going to have a horizontal translation. So I have a horizontal translation. It's going to be the opposite of positive, which means I'm going to go left 4. My x's are always negative 8, negative 1, 0, 1, and 8. And to fill in my table, I'm only going to use that portion of my original problem. So y equals negative 3 times the cube root of x. If I put negative 8 in for x, the cube root of negative 8 is negative 2. Negative 2 is then multiplied by negative 3, which would get me positive 6. The cube root of negative 1 is negative 1. Negative 1 times negative 3 would be positive 3. Cube root of 0 is 0. 0 times anything is going to get me 0. Cube root of 1 is 1. 1 times negative 3 is negative 3. And the cube root of 8 is 2. 2 times negative 3 would be negative 6. Go ahead and plot those points. So I go left 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 6, 1, 2, 3, 4, 5, 6. Then I go left 1 and up 3, have 0, 0, right 1, down 3, and right 8, 2, 3, 4, 5, 6, down 6, 1, 2, 3, 4, 5, 6. Need to connect all of my points. Now I need to go ahead and take care of my horizontal translation left 4. So I'm going to take this point left to the left 4 places, this point left 4 places, this point left 4 places, this point left 4 places, and this point left 4 places. Go ahead and connect all of my points. As you can see, my graph will go right and left forever. It will also go up to the left forever and down to the right forever. So my domain is all real and my range is all real. Well, that is the end of our note sheet. The most important thing to remember here is this is going to be extremely close to what we do with the square root functions. Your domain and range, if I have a cube root, are always all real. And the x values in my table are always going to be negative 8, negative 1, 0, 1, and 8 when I have a cube root function. Remember, if you have any questions over this stuff, come in and see me. Otherwise, thank you very much for watching the video, and have a great day.